a probability of selling a TV will be a 30% usual days. But given that a probability of selling a TV on Diwali will be 70%. They've asked you to calculate A union B. Let me take it as 2 times of P of A. They have given it as 5 by 13. So what is P of A? Cross multiply 2, which is 5 divided by 13 2s are 26. So what is the probability of drawing? They've asked without replacement. This is very, very important. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Dear students, in today's session, we'll be moving on to the new chapter, which is very, very important and interesting chapter for you all, dear students. Chapter number 13 of your second PUC Mathematics called Probability. This is very nice chapter, dear students. You can enjoy here. Now, we'll be moving on to this session here. Session number 1 we are having, and we are going to have the basic definitions of this probability. And here, we are going to expect from this chapter, 1 marker 1 question will be there, dear students, 2 marker 1, 3 marker 1 question, and 5 marker 1 question, dear students. And then here, you are going to have totally 11 marks. And then here, we'll be moving on to, before moving on to the probability definition, here we are having what are all the definitions of simple things we are going to have in the probability case. Now here, probability means what? Now, for example, if I am going to say it as, it may rain today. It may rain, it may not rain, isn't it? So that is what the probability you cannot, that is guess. That you can have only the predictable, but you cannot have the same thing, it will happen there, right? So that is going to be known as the probability. That is an example I have given, that's it. Here, the first definition will be moving on to what do you mean by the random experiment. So the random experiment means here I am going to take it as an experiment in which all possible outcomes, this you have to note down, all possible outcomes are known. You know that what are all the possible outcomes it will come there, okay? But in advance, you know, and exact outcome in any specific trial of the experiment is unpredictable. For example, I am going to take it as you have heard many times this example, tossing a coin. Tossing a coin, you know what are all the possible outcomes it will come. Either head it will come or tail it will come, isn't it? But you don't know exactly what outcome it may happen when you're going to toss a coin. Isn't it? That is going to be known as the unpredictable. That it is going to be as a random experiment. I hope you understood this definition. Now, we'll be moving on to the next is nothing but a sample space. Sample space means what? A total number of outcomes you are going to count. That is going to be known as a sample space. In a definition, if you want to tell exactly the set of all outcomes in a random experiment is called as a sample space, and it is denoted by S. So the number of sample space, it is denoted by what? N of S. Okay. So the number of sample space is going to be known as N of S. For example, tossing a coin, what is the number of sample space? Head and tail, which is nothing but 2. That's it. Okay. Now you're going to have event. Next, what do you mean by an event? An event is nothing but it is a subset of a sample space. That is a subset of a sample space. We are going to denote it as yes is called as an event. Okay. For example, you are going to have tossing a coin. Next, tossing a coin only when it is head. So head, obviously, tossing a coin, you are going to get head and tail. Number of times of head is nothing but only 1 time. So number of head is nothing but a subset of a sample space. That's it. That is an example. And also, we are going to have null set. Null set is defined as what? An empty set. Okay. So empty set is denoted by 5. The 5. Okay. It is also a subset of the sample space. For example, number of green ball drawn, set of red balls. Isn't it? How you can draw green ball if it is only set of red balls? It is impossible, right? So that is going to be known as what? A null set, which is going to be known as a impossible event. That is what. See, drawing a green ball out of set of red balls, it is an impossible. That is going to be known as the empty set, which is going to be as impossible event. You understood now with an example? Yes, I think you are following. Now, since S is a subset of S, so S is an event which is going to be called as a sure event. So if S is a subset of S, that means universal set if you are going to call it as. So that is going to be known as a sure event. That's it, yes. So these are all the definitions you are going to have. Still we are moving on to the definitions of some definitions. I am going to give you an example so that you can understand really better. Now we'll be moving on to the next is nothing but complementary event. What do you mean by a complementary? Complementary is nothing but if E is an event, complementary of an event is nothing but E bar or E dash. That is going to be known as the complementary event. Okay, and here if probability of event E bar is given by 1 minus probability of E. So this is a formula you have to remember. Complementary of event is nothing but probability of E bar is equals to 1 minus probability of E. That's it. Now here next we'll be moving on to mutually exclusive events. Now under the definition what it will come? Mutually exclusive events means two events A and B are said to be mutually exclusive if A and B, see this is going to be known as AND. A and B is equal to an empty set. So mutually exclusive, okay? That is going to be known as if A and B are mutually exclusive, then A intersection B will be is equals to an empty set. That's it. So, for the better understanding, if you want, what do you mean by the mutually exclusive event means at a time running, walking. It is possible? No, it is never. Losing a game, winning a game. It is impossible, right? So that is going to be known as what? A mutually exclusive event where A intersection B will be is equals to a empty. That's it, yes. And then if you, what is that? You're going to toss or die. Possible of even number and odd number. It can be possible at a time? No. Either you have to get an even number or you have to get an odd number. Isn't it? Both at a time it cannot be possible. That is going to be known as a mutually exclusive event. That is a real-time example I am giving. What is that? Running, walking. What is that? Losing a game, winning a game. At a time it cannot possible. So there the intersection of that two sets will be is equals to what? Empty. That is going to be known as mutually exclusive event. I hope you understood by this example, right? Now we'll be moving on to the next is nothing but independent event. Dears, the independent means the word itself says that independent means one event does not depend on the other event. That is going to be known as independent event, dear students. So here by the definition says that two events are said to be independent if occurrence of one does not depend upon the occurrence of non-occurrence of the other event. That is going to be known as what is that? Independent event. For example, here one coin, here one coin. Tossing this coin, you are going to get a tail. Tossing this coin, you are going to get a head. But this event does not depend on this event. That's it. That is going to be known as independent event. So one event occurrence will be not dependent on the other event occurrence. That's it, yes. How easier to understand all these definitions and how that is in the real day-to-day life if you take in probability, how easily you can give an example with that, isn't it? Now, we'll be moving on to the next is nothing but here what I'm going to take it as in mathematics. If E1 and E2 are the two events, then we are going to have, if they are independent events, then the formula will come like this. Probability of E1 and E2. E1 and means what here? Intersection. E1 and E2 can be written as probability of E1 into probability of E2. This definition you have to remember when they have given a situation of independent event. That's it. Now here we'll be moving on to also their complementary events are also independent. Complementary event is nothing but what? A P of E1 bar and P of E2 bar, which is 1 minus P of E1 and 1 minus P of E2. That's it. Okay. Now, next we'll be moving on to the probability condition. What do you mean by a probability? A probability means in a random experiment, you know already what do you mean by a random experiment? It is known that outcomes, but it can, what is that? It is unpredictable. It is going to be known as a random experiment. So, in a random experiment, let S be the sample space. What is a sample space? The number of possible outcomes is going to be known as a sample space, and let E be the event. You know what do you mean by an event? Subset of the sample space is going to be known as a event, isn't it? Then we are going to have P of E. That means probability of an event is defined as number of distinct elements in E divided by number of distinct element in S. That means number of outcomes, that is a favorable outcomes of E divided by number of all possible outcomes. For example, there are many colors of balls in a set you may have. I may like black color, you may like red color, right? So that is what the favorable outcomes, that's what you are going to have, favorable outcomes of E divided by number of all possible. How many red ball can be drawn, how many black ball can be drawn, that is what all possible outcomes. So that is denoted in a format is nothing but N of E divided by N of S. That's it. So this is what you have to know easily. What are all the definitions you are going to have under the probability, and what do you mean by exactly the probability. And based on this also you have to know some formula, dear students. Suppose if they have given probability of A or B, then how to write the formula. So probability of A or B is given by A or B. Remember, or means here union, which will be is equals to probability of an event A plus probability of event B minus, you are going to minus probability of A and B. Dear students, and means intersection, or means union. Okay, that you have to remember. Suppose if they ask you to calculate probability of A and B, then the formula is given by probability of A plus probability of B minus probability of A or B. Okay, so that only I am specifically writing here. Union means or, and then intersection means and. This you have to remember. Okay, and then you are going to have here if it is a mutually exclusive event. What do you mean by mutually exclusive event? I said an example, at a time walking and running it is not possible, right? That is called mutually exclusive event. At that time, what is A intersection B? It is an empty set. Empty means what? 0. So if it is a mutually exclusive event, then you are going to have if A and B are mutually exclusive event. MEE I am writing. Then P of A or B is given by P of A plus P of B. Why? Because P of A and B will be is equals to 0. So that P of A or B is equals to P of A plus P of B. So next you have to take care of what do you mean by conditional probability. So conditional probability means probability of an event A given that an event B is already occurred. Understood? Probability of an event A given that already the B event is occurred. That is going to be known as the conditional probability. You want me to give a day-to-day example? Yes, you can take it as, that is, a probability of selling a TV will be a 30% usual days. But given that a probability of selling a TV on Diwali will be 70%, that is going to be known as conditional probability. Ma'am, then what is the formula for conditional probability? If I am going to take it as E and F are the two events, then conditional probability is given by conditional probability. Probability is given by, dears, consider that E and F are the event, then probability of E over F. E over F means probability of event E given that F is already occurred. Okay. So it is given by probability of E intersection F divided by probability of F. This you have to note down. Suppose probability of F, if already E is occurred, then it is given by probability of E intersection F divided by probability of E. So this formula you have to remember. Okay. So all this formula you have to remember to solve the problems. Similarly, if they have given three events, A, B, C are the events if they have given, then what is the probability of A or B or C? So let me write that one. If A, B, C are the events, okay. If A, B, C are the event, then probability of A or B or C is given by probability of A plus probability of B plus probability of C minus probability of A and B minus probability of B and C minus probability of A and C plus probability of A and B and C. So this you have to remember, dear students. Okay. So these are all the formula you have to remember to solve the problems. Understood? So now, dear students, based on this all formula, we'll be solving the problems. Now here, first I have taken example to make you to understand still better. Now here, consider an experiment of tossing 3 coins. That means 3 fair coins. That means independent. The sample space of an experiment is what? 2. So 3 fair coins. So what is the sample space of an experiment? Sample space of an experiment you may get in all the 3 coins head, 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 or you may get it as head, head, tail. You may get it as, what is that? Head, tail, tail. You may get head, tail, head. Isn't it? So all the possible cases I have written here, which is all 3 can be head, or 2 can be head, 1 can be tail, or 1 is head, another is tail, 1 more is head, and here 1 will be tail, another will be head, 1 more will be head, and here and one will be tail, middle one will be head, and last one will be tail. Similarly, first one and second will be tail, third one will be head. All 3 can be tail. So this is nothing but the sample space. So totally how many number of space you are going to have? Number of elements in a space, that is n of s will be is equals to see 1, 2, 3, 4, 5, 6, 7, 8. So totally 8. That means you can have 2 power 3. What is that? 2 power 3. So which will be is equals to, you can write it as 2 power 3. That's it. Now here I have taken, since the coins are fair, we can assign the probability is nothing but each will be is equals to 1 by 8. So 1 by 8 means what? You are going to have at a time only this you can expect. That means probability of all 3 are head means only 1 you can expect. Probability of all 3 are tail means only 1 you can, 1 out of 8. That means 1 out of 8. Similarly, probability of this, 2 are head, 1 is tail. Only this one. Only this one you are having. So 1 out of 8. So each will be how much? 1 by 8 to each sample point. Understood? So here, so in theory, what is the ideal coin you are going to know as? That is a fair coin. That's it. Okay. So here, what is that? The probability of each, it will be is equals to 1 by out of 8 sample point. Understood? So here we are going to have, let E be the event, at least 2 heads appear, and F be the event, first coin shows tail. So first coin it will be showing a tail and leg 2 it will be a head. You can expect only this, first coin showing tail and 2 it will be a head, isn't it? So this is what you are having here. See, first coin shows tail and 2 it will be a first. What we have taken? What is that? Event E is nothing but at least 2 of them it will be head. At least 2 must be head. At least 2 must be head means what? At least here, see, 2 must be head. This is one and this is another one, 2. At least 2 head. At least 2 head. They have not given that first coin will be a head like that, isn't it? So that's it, right? So these are all the event you can expect in event E. That is what here. See, H, 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 T, H, T, H, H, T, H, H. Got? Next, I have taken that event first coin shows tail. First coin shows tail. First coin shows tail. What is that? This one, and this one, this one, and this one, isn't it? That is what first coin shows tail, right? So here, first coin shows tail. Now here, I have taken therefore probability of E is nothing but probability of only HH, probability of only 2H and tail, probability of HTH, probability of THH. That means each it will be this 1 out of 8, this is 1 out of 8, this is 1 out of 8 as I shown. This is only 1 out of 8. So this is only 1 out of 8. Only we can have at a time 2 heads in 2 coins, last will be a tail. Only one event is occurring, isn't it? That is out of 8. That's what I have taken here. Probability of E will be. So totally it will be 1 by 2 if you calculate this one by taking the LCM. That's it. Okay. Now next we'll be having probability of F will be what? This is 1 out of 8, 1 out of 8, 1 out of 8 and 1 out of 8. Totally it is also 1 by 2 only. But if you have E intersection F, what is common? What is common, dear students? E intersection F. Common is nothing but you are having THH, THS. That is a common. That is what I have taken. THS, how many times it is a problem? Out of 8, 1 time it is occurring. That is what a probability of E intersection F is also 1 by 8. I hope you understood this one. E intersection F means what? E and F. Okay, E and F. That's it. Now, we'll be moving on to what I told, the conditional probability. Already you know that P of E by F, number of elementary events of a favorable in E intersection F divided by number of elementary events which are favorable to only F. That means probability of event E, already F is occurred. That is going to be known as P of, that is N of E intersection F divided by N of F. That is a probability. And here also P of E by F is given by probability of E intersection F divided by probability of F. Similarly, if F by E means probability of F, already the event E is occurred means ulta. Probability of E intersection F divided by probability of E. So these are all the formula of the basic things of the probability you have to know to solve the problem. Dear students, now we'll be moving on to the problem what they have given. So here, if P of A is equals to 7 by 13, P of B is equals to 9 by 13, P of A and B is equals to 4 by 13 and evaluate P of A by B. That means A by B means P of A, that event B is already occurred. What is the formula of P of A by B? P of A by B is given by P of A intersection B divided by P of B is already occurred, right? So therefore, it is given by, already substitute the formula. What is P of A intersection B? P of A intersection B is nothing but you are having already given 4 divided by 13 over, they have given P of B is nothing but 9 by 13, right? So 13 will get cancelled. So you are going to have it as P of A or B is given by 4 by 9. That's it. Okay. We'll be moving on to the next problem, dear. What they have asked. Given that E and F are events such that P of E is 0.6, P of F is 0.3 and P of E intersection F is 0.2. Find P of E by F and P of F by E. You know what is P of E by F? P of E by F is given by P of E intersection F divided by P of F. Substitute. What is E intersection F? 0.2 divided by P of F is nothing but 0.3. Right. So, which is nothing but you can have, if you multiply throughout by 10, you can write it as 2 by 3 or 0.6. That's it. That's what they have asked here. Next, let us calculate what is P of F by E. That's what they have calculated. That's what they have asked here. P of F by E is given by P of E intersection F divided by P of E. Now, P intersection F is 0.2 divided by P of E is nothing but 0.6. So, you are going to have 2 by 6 or nothing but 1 by 3. That's it. Okay. This is what you are going to have it as. Now, we'll be moving on to the next problem. What they have given? Compute P of A by B, conditional probability. If P of B is given 0.5 and P of A intersection B is 0.32. Now, here, what is P of A by B? Which is given by P of A intersection B divided by P of B. So, which is nothing but A intersection B is 0.32 divided by P of B is 0.5. Right? So, which is given by, if you multiply by 100, you can have 32 divided by 50. So, otherwise, you can cancel this by 2. So, which is nothing but 2 ones are 2. So, which is 2 6s are, right? So, 16 divided by here, 2 2s are 4. Next 10, 2 5s are 25. So, 16 divided by 25 is your answer. How easier to calculate if the formula is known, dear students, right? Now, we'll be moving on to the next problem. What they've asked, if P of A is 0.8, P of B is 0.5 and P of B by A is 0.4, find P of A intersection B, that is P of A and B, P of A by B and P of A union B. Now, here, let me write what is P of B by A. So, P of B by A is given by the formula P of A intersection B divided by P of A, right? So, already P of A is given. Let me substitute here. P of B by A is what? 0.4 is equals to, we don't know what is P of A and B, but we know what is P of A, which is 0.8. Cross multiply. So, P of A and B, which is nothing but the first one you can have, which is equals to 0.4 into 0.8, right? So, 0.4 into 0.8, which is nothing but 0.32. That is what a P of A intersection B of P of A and B, okay? Or P of A and B. Now, first one is calculated. Let us move on to the second one. Second one, they have given that P of A by B, which is given by P of A intersection B divided by P of B. Substitute P of A intersection B is 0.32 divided by P of B. They have given it as 0.5. So, if you multiply, you can get it as 32 divided by 50. Otherwise, 16 divided by 25 if you cancel by 2. Correct? 2 16s are, 2 25s are. Next, they have asked third one, P of A union B. So, what is P of A union B is given by? P of A union B is given by P of A plus P of B minus P of A intersection B, which is P of A is 0.8 plus P of B is 0.5 minus P of A intersection B is 0.32. Let us add up and subtract. So, you are going to get it as, so 1.3 minus 0.32 is nothing but 0.98. 0.98. This is what the third one answer or sub question 3 answer, 0.98. Understood? So, I hope you got this problem. Now, we'll be moving on to the next problem. What they've asked. Evaluate P of A union B if 2 times of P of A is equals to P of B is equals to 5 by 13. That means P of B is 5 by 13. 2 times of P of A is 5 by 13 and P of A by B is equals to 2 by 5. They've asked you to calculate A union B. Let me take it as 2 times of P of A. They have given it as 5 by 13. So, what is P of A? Cross multiply 2, which is 5 divided by 13 2s are 26. So, next they have given it as P of B is nothing but directly 5 by 13. And then also P of A by B, they have given it as 2 by 5. Correct? So, here evaluate P of A union B. We want P of A intersection B also. They have given already P of A by B. Formula is P of A intersection B divided by P of B. Correct. P of A by B is 2 by 5 is equals to P of A intersection B. We don't know, as it is I am writing, divided by P of B. We know that 5 by 13. Now cross multiply, you are going to get it as P of A intersection B will be is equals to 2 by 5. If you cross multiply, you are going to get it as 13 divided by 5, isn't it? So if you are going to cross multiply, you are going to get it as 5 by 13 as it is, because it is in the denominator. 5 will get cancelled, remaining is 2 by 13, right? So you are going to get the answer P of A intersection B is nothing but 2 by 13. Now substituting this P of A intersection B to calculate P of A union B. What is the formula for P of A union B? P of A union B is given by P of A plus P of B minus P of A intersection B. So which is nothing but P of A, you are having 5 by 26 plus P of B is nothing but 5 by 13 minus P of A intersection B is 2 by 13. Now if you take the LCM, you can get it as, so 26 is the LCM. So here 5, 13 2s are 26, 5 2s are 10. Again here 13 2s are 26 means 2 2s are 4, minus 4. So 10 plus, here 10 minus 4 is 6, 6 plus 5 is 11. So therefore you have 11 divided by 26 as your answer. That's it, yes. I hope you understood this problem how to solve. Now we'll be moving on to the next one. If P of A is 3 by 5 and P of B is 1 by 5, find P of A intersection B. Find P of A intersection B if A and B are independent events. So if A and B are independent event means P of A union B is given by P of A into P of B, isn't it? So given if A and B are independent events means P of A intersection B will be P of A dot P of B. So given that A and B are independent events, right? So therefore you can have P of A intersection B will be is equals to P of A into P of B. Understood? Now you can have, what is P of A? P of A is given by 3 by 5 and P of B is given by 1 by 5. So the answer you are going to get is as 3 divided by 25. That's it. So P of A intersection B is nothing but 3 divided by 25. That's it. Now we'll be moving on to the next one. A family has 2 children. What is the probability that both children are boys given that at least one of them is a boy? So let us consider, let the boy represent B, okay, and girl represent BG. So here let it be 2 children means what is the probability both the children, what is the sample space then? Sample space will be is equals to either both of them will be boy, correct, boy, or both of them will be girl, one boy, one girl, or one girl, one boy, or both of them will be girl, right? This is what the sample space you are going to have. So number of yes will be is equals to 4, correct, isn't it? So next they have asked, given that at least one of them is a boy. So let E be the event that is a boy. So let E be the event, is a boy. One of them is a boy means what is the condition you are having? Girl will go. One of them boy means these it will come. So P of E will be is equals to what? So probability of E will be is equals to 1, 2 and 3. It will come, isn't it? So here they have asked you to calculate a probability of that. Only it is a event out of how many? Out of 4. So probability of event E will be is equals to 3 divided by 4. That is the answer. Okay. So given that here we have calculated number of sample space is nothing but 4. I am going to take it as what is the probability of that both the children are boys. So let E be the event, both the children are boy, both are boys, right? So what is the probability of E? Probability of E will be only 1 because this is only 1 you are going to have, isn't it? So next, probability of both the children are boy out of what? Out of 4. So 1 divided by 4 you can have it as, right? Similarly, let F be the event, at least one boy. At least one boy, right? At least one boy means what is the probability of F? Probability of F means either this, this or this. So 3 out of what? Out of 4. So 3 out of 4. But what is the probability of E intersection F? In both are common. Boy, boy is here. Here only boy. See, here only boy, correct? Boy and boy, right? So here what? Here it is boy, boy. It may be boy, girl. It may be girl, boy, right? But what is both in common? Boy and boy. So probability of E intersection F will be is equals to 1 out of 4. That's it. This is what you are going to have it as. Now here they have asked you to calculate both the children are boys, at least one of them, given that at least one of them is a boy. That's it, right? Now we'll be moving on to the next one. 2 cards are drawn at random without replacement from a pack of 52 playing cards. Find the probability that both the cards are black. How many black cards are there? So there are 26 black cards, 26 red cards, isn't it? So in a 52 cards, there are 26 black cards and 26 red cards. So we are only talking about the black card now. So what is the probability of drawing? They have asked without replacement. This is very, very important. Without replacement from a pack of 52 cards, find the probability that both the cards are black. Now first time when you draw, how many it will be? So probability of drawing, first black card. First black card. Out of what? Out of how many black card? Out of 26. Correct. In a pack of how many? 52 cards, right? 52 cards. So probability it will be what? So therefore probability it will be, let me call it as event. So probability of this event E will be is equal to 26 divided by 52. Right. So 26 divided by 52 is nothing but 1 divided by 2. Isn't it? 26 twos are, which is nothing but 52. Next. So probability of drawing second card. Probability of drawing second card. That is second black card. How much it will be? Already one card will be drawn. So out of 26, how many is remaining? 25. Out of 52, how many remaining? 51. Correct. One card is already drawn. So therefore, in total number also it will be come down. In black card also it will be 1 minus, right? So 25 divided by 51. So probability that both the cards are black is nothing but probability. Let me call this as event as P of F. So probability of E intersection F is nothing but one is not dependent on other. So which is nothing but probability of E intersection F is probability of E dot probability of F. So which is equal to probability of E is 1 divided by 2 into probability of F is 25 divided by 51. So total 25 into 1 is 25 divided by 51 into 2. So 2 ones are 2, 2 fives are 10. So which is 102. So this is what the probability you are having. Okay. So what is the next problem they have given? Here they have given a family has 2 children. What is the probability that both the children are boys given that at least one of them is a boy? Given that means what it is? It is a conditional probability. First let us calculate a probability both the children are boys. First let us calculate the sample space. What is a sample space? So sample space is given by both it may be boy. Correct. I am call it as boy will be let B, girl will be let G. First one may boy, second one may girl. First one may girl, second may boy. Both the girls First one and second one both may be girls. Now here, what is the probability of an event? Let E be the event. Both are boys. Both are boys. So what it be? E will be is equals to only both are boy means boy, boy. But what is the probability of E? So P of E will be is equals to only 1 out of 4. Is it? 1 out of 4. Similarly, let F be the event. Let F be the event. Let F be the event. At least one of them is boy. At least one of them is boy. So what is that? So F will be is equals to at least one of them means boy, boy also will come. Boy, girl also will come. One of them is boy, right? Girl, boy also will come. But girl and girl will not come. Why? Because both are girls there. At least one of them will be boy. What is the probability of F then? Probability of F is 3 by 4. Isn't it? But what is probability of E intersection F? What is common in both? B, B, B is common. So probability of E intersection F will be is equals to 1 out of 4. Now they have given that both the children are boys, given that at least one of them is boy. So you need to calculate probability of, what is that? At least one of them is boy means already given, already occurred. So E divided by F. So which is nothing but probability of E intersection F divided by probability of F. Substitute E intersection F is 1 by 4 divided by probability of F is 3 by 4. So 4 will get cancelled. The answer is 1 by 3. So probability of both the children are boys, given that conditional probability, what is that? At least one of them is a boy occurred already. Okay. So given that already, what is that? At least one of them is a boy. That is what the conditional probability I have calculated. So that is what the conditional probability I have calculated. Okay dear students, in the next session we'll be moving on to some more problems of this probability. Until then, keep watching dear students. Have a nice day. Thank you.